Now, um, today we're finally getting into the real perms and coms, or just working with permutations today. Last class, it was very simple just to get you into it. Okay, now we're going to get into the reality of how many ways can I do this if there are repeats. Now, what does that mean? Okay, well, if you look at this word, R-O-S-E, just look at that. There's no repeats, right? So this is going to be, how many ways can I do this? That's 4 times 3 times 2 times 1. That's easy. Okay, but what about Ross? How many ways can I make unique, different permutations of Ross? Now, do you see how if you take these two and mix them up, does it make a different word? Yes. If you take these two and mix them up, does it make a different word? No. Okay? So we're not going to say that's a red S and a black S, because that's even different. Because then they do look different, don't they? If you moved them. But because they're both the same letter, there's not as many permutations on the second one, because Ross is the same thing as Ross. Okay? Now, how are we going to deal with that? And what about this? What if I said every word has to start with S? Or what if I said in rows, O and E must be together? Or I said that O and E must be together in that order. Okay? Or I could say O and E must be together, and it must start with R. How many different ones are there? Okay? Now, those are the types of questions that when you're in an exam and someone's chewing gum beside you, or someone's got a runny nose beside you, or whatever, you do want to kill them. Okay? Because you're like, okay, well, I can't get this, and all you can hear is, whatever, right? So, you'll find that these ones take so much concentration that little distractions, are very frustrating. So, I'll be the first one to admit, I don't like these, okay? But, with that said, I have come up with strategies to be able to get you through this kind of question all the time. And if it says this, always do this, okay? So I think I've got every scenario covered only through having to endure eternal pain to get these things, okay? So I'm going to pass the savings on to you and tell you, okay, this is what I've found. When you get ones like this, do it this way, okay? This keyword here, do it this way, okay? And that kind of takes the mystery out of them, because when you first go through these, you're like, what? Why did they do that? And sometimes the book skips how they did it, and they have 5 factorial times 2 factorial. You're like, what? There's like 8 letters. Why did they do that? Okay? So I'm even going to show you how using the very first method we ever learned is actually the simplest way to do many of these. Now, with that excellent introduction, let's get at it. Yes, thank you. The first way we're going to start is if I had just all the letters oranges. Now remember, these are like little tiles, right? Little Scrabble tiles. How many different, it's not like I'm taking letters out of an alphabet where I could use N 12 times. I can't. I can only use N once because I've taken it out. Bang, there it is, right? There's no more N's, okay? So if there was no restrictions, aka last question or last objective we learned, what would be the number of ways I could make? Okay, how would I do it? 7 times 6 times 5 times 4 times 3 times 2 times 1, right? So that's 7 factorial, which is 5,040. Okay? Now, that makes sense, right? Now, what if we start doing restrictions? The first letter must be an N. So it would be 1 times 6 factorial, right? 1 times 6 times 5 times 4 times 3 times 2 times 1. Okay? Which is now 720. Isn't it amazing how if you just give me one piece of information, how much the number of different ones decreases by? Because you know what? 720, say you were like trapped in a cave and you had to figure out a combination. 720, you're not going to be there for a week. Okay? If you had a piece of paper and a pencil, you could make sure. I mean, you got nothing else to do there, right? Trying to get out of a cave. I was actually, this is no lie, I was actually in a cave that had this huge door and went behind it because they didn't want people, and then you climbed down this long ladder and then you went through this cave. And because they, kids, when they learned to like where it was, whatever, they'd go party there, and they didn't want the cave wrecked. So this huge metal door, and you actually had to, there's a hole, you had to reach inside to unlock it, right? So you couldn't even get an axe or whatever to chop it, right? So let's just pretend it's got a combination lock on it. And you remember when he put it in, the first one, okay? And you got locked in, you got left behind, you fell asleep in the cave, they left, and you're in this, right? So just knowing the first one, takes 5,040, because if you didn't know the first one, down to 720, okay? Now what if the vowels O, A, and E must be together and must be in that order? Sorry? No. C will it starts new. Okay? So, this is how I look at it. O, A, and E, they're like one thing now, right? They're like a little group. So if I make them one thing, how many things do I have? How many? 5. Therefore, I would have 5 things, okay? Because it's not counted as a bunch of things. It's like one thing now. So that would just be 5 factorial. Because there's OAE, they're one thing, and then R, N, G, S. These are all my things. It's like, how many ways can I rearrange those things? Actually, want to hear a cool story the guy told us when we were in the cave? Because he has to lock the cave behind him when we're in, right? And you'd go down this, and there's a platform, and then you go down this long ladder, and then you go in these caves. It was pretty cool. I was like 15 or whatever when I did it, but I still remember it. And he said one time, it was like some older people, and they were going down, and this one lady was like getting claustrophobic. And she's like, I got to go back. And he's like, hey, that's cool. Do you want me just to, open the door and you can go out and just sit out there? And she's like, no, I'm okay. I'm good. I'll just sit at the top. Okay, so she sits at the top. And because there's enough light coming through the hole, right? Because you had to reach in and do that lock. And while she's sitting there, a bunch of kids came down, right? And they were kind of like around there, whatever. And they were trying to get in, right? And she didn't say anything. One kid reached in to grab the lock, and all she did was lightly grab his hand. He lost it, right? And to this day, I bet you that kid has no idea what happened, like what is living down there, right? I bet you anything that kid, because they were out of there. And I was thinking about that kid. Is he thinking like he's probably like in therapy once a week, right? Working through that. Now, how many arrangements of the letters of the word brains and the vowels have to be together? So, what becomes a group now? AI. Okay, so AI is a group, and then B, R, N, S. So that would be, how many ways could I do that? 5 factorial. But did it say that A and I had to be in that order? No. So there's also these, IA, B, R, N, S. Which is 5 factorial. So this is an OR, right? So that would be plus, and that would be 240. Now here's the way I do these all the time. I go number of groups, factorial, times the group number factorial. So if there's 5 groups, I go 5 factorial. How many things in the group? 2. If there was 3 things in the group, I would go 5 factorial times 3 factorial, because I can arrange in the group 3 factorial. Okay? So this way works all the time. Number of groups times the things in the group, I should probably say, factorial. So number of groups times the things in the group, factorial. Okay? And again, as you're doing the homework and you're making a study sheet, again, what's that study sheet for? To organize all your thoughts, okay? This is what I will do every time I get this type of question. Now, why is this one different than this one? Are you differentiating well? Okay? I attribute that to the high success you guys are getting on your exams. You're not mixing up a lot of thoughts. Very few of you are. Okay? And that is, ask any teacher at Edmonton Public, that is the biggest problem that we're running into our math classrooms, is they're taking this rule and they're doing it over here, and they're taking this rule and they're doing it over here, right? They just memorized a bunch of rules and they're like, I don't know when to do it, okay? It's frustrating. And that's what when we get to the diploma and you've got your study sheets, it's going to help you differentiate more. Because the problem that you will not run into is not knowing the information. It's not knowing when to use it. That's going to be the problem. And mixing it up here and here. Okay? So you've already come up with something to always do. If they're saying these have to be together, not in that order, so they don't say the order, you're going to do it this way. How is that different than the ones where they stay in that order? Okay? Do you know the difference? That is important. In fact, that is what the gist of this entire unit is can you just walk up to any situation and know how many different ways I can arrange them? Now, let's look. It says find the number of permutations in the letters of the word kitchen if K, C, and N must be together, but not necessarily in that order. Therefore, how many groups would we have? We've got KCN is one group, and then the rest, right? So we have 5 groups, right? Times, now KCN can be KNC, can be, so by 3 factorial, right? which equals 720. So that is very much like the question above. Now, if you're looking at 3 and 4 and you're going, hey, that's the same question, then you're getting it, okay? Now, B is a toughie. The vowels must not be together. How would you do that one? 4 factorial times 2 factorial. Okay, so you're going 5 factorial. So you're saying there is 5 groups. But I and E cannot be together. Okay, tell me how you would set it up. It's good to think these through and know why they don't work. Okay. B is one of those questions that you can take a half an hour on an exam and not even know where the time went. Because look how short it is. It's 5 words. How hard could that be? Right? And people do that. This isn't hard. I can get this. And I'll tell you, if you don't know how to do this, you are in a world of hurt. Okay? So this is the strategy to do these. Whenever you get must not be together, always. So when must not be together, you always use the complement. Okay? The complement in mathematics means the exact opposite. Okay? If you guys are teenagers, you know exactly what the complement means, right? If you're mad at your parents and you want to get them back and they ask you to do something, I guarantee you're doing the complement, right? And you're going, oh, sorry, I didn't know, I didn't hear you, okay? I think a few of you can think of a couple examples, I'm sure. So, here's how you do it. The complement, so when must not be together, it is the same thing as no restrictions minus the complement. Okay? So no restriction means the free-for-all minus the complement. I bet you that is. The leftover should be the complete opposite. Now, no restrictions would be 7 factorial. What is the complement of the vowels cannot be together? The vowels must be together. Okay? So how about 7 factorial minus vowels must be together? How would you do vowels must be together? What is it? 6 factorial, 2 factorial. So if so IE is a group, right? And then it could be IE or EI. Through every one that you could have done, you're going to switch. So it's 7 factorial minus 6 factorial, 2 factorial equals 3,600 ways. Okay? So, again, I know what you guys are thinking. You're like, I would have never thought of that in a million years. Well, that's why you're here. Okay? If you knew this stuff already, why would you be here? So, but we're coming up with things that you can start knowing exactly what to do in this situation and this situation, okay? And that will only come through doing the homework and having a good study sheet that is well organized, okay? Now, in how many ways can 3 girls and 4 boys be arranged if no 2 people of the same gender can sit together? Now, there is a unsaid thing about what's going on here. Because I know we're thinking it could be boy, girl, boy, girl, boy, or girl, boy, girl, boy, girl, boy, girl, boy. They have to alternate. We know that. But we know something else. It has to start with a boy. Why? Yeah, if you did girl, boy, you'd come up with, it wouldn't work. It just wouldn't work. So this is how I do it. I go totally old school on this one, and we have 1, 2, 3, 4, 5, 6, 7. Okay? And this has to be boys, right? Okay? So again, here's another, this is a totally different scenario than the other two, than everything else we've done before. You're starting to see, oh yeah, I couldn't use that one. This isn't where 2 are together or anything. So how many boys can sit in the first seat? 4, 3, 2, 1. Now it's girl, girl, girl. How many girls can sit in the first one? 3, 2, 1. What's another way I could write this? Yeah, 4 factorial times 3 factorial. Now, really, if the book just had that, you guys would be so messed up. You'd be like, 4 factorial times 3 factorial. Like, why? Well, they just took the 4 times 3 times 2 times 1 in the middle. So this is actually distracting. Okay? I think that the way that I set it up, people can go, yeah, I get that. Okay? And then, well, that's, see the thing in circles? I think in red circles, that is 4 factorial. And you're like, oh, yeah, okay, I get that. Okay? So if you went 4 times 3 times 3 times 2 times 2 times 1 times 1, right, in your calculator, that's going to make sense to you. Okay? So for that one, I would go with the fundamental counting principle to do that one. Order matters, and it's, you know, and on your study sheet, you're going to be like, in this type of question, okay, because a boy came along and he had like 4 tractors and 3 trucks, and the tractors couldn't be beside the trucks. How many ways? I hope you're not going, man, I knew how to do this with boys, girls, but trucks and tractors, oh crap, I'm messed up now, okay? So that's what I'm trying to get you to think. That, oh, that's that type of question. I know to do that one. I remember that one. Okay? Now, we have 6 actors. 8 actresses are available for play with 4 male roles and 3 female roles. How many different cast lists are possible? Okay? Now this one's a little bit weird now too. This is a different type. Any suggestions on how you do this one? Yeah, let's go with that. No, it could be professional play, that could happen too. But yeah, trust me, the diploma hopefully has gone through this, and yeah. And it might say that the females are playing female roles and the males are playing male roles. Because it even says actresses. You're not even allowed to say actresses anymore. It's actors. Everybody's an actor. Okay? Okay. Now, are we saying they have to be picked in this order? We're just saying we need 4 male roles and 3 female roles. Now, if you start with the male roles, how could you do that? Six, 5, 4, 3, and female? 876. Now, again, I'm thinking this probably makes sense, but what's another way I could write this? No, you can't do 8 factorial. Oh, you'd have to go 8 factorial divided by 6, because, you know. But here's another way you could do that. I have 6 male roles, and I'm picking 4, times there are 8 female roles, and I'm picking 3. So it's, see, 6 times 5 times 4 times 3 means 6p4. And what would the 4 stand for? Yeah, the number of rows. So that's my number of blanks. Do you see that? So we have to be able to identify that those are equivalent ways of writing it. Again, this one, sometimes people say, well, that makes more sense. 6 picks 4, and I have 8 pick 3. I like that. That's quicker, and I kind of understand that more than the blanks. Okay? And the permutation is, to many people, more understandable, because you're using the word pick. I have 6 roles, I'm picking 4. Okay, I have 8 roles, or 8, sorry, not 8 roles. Scrap that. I have 8 people, 8 males, 8 females, and I'm picking 3. And I have 6 males, and I'm picking 4. Okay? Oh, I should even, it's funny that I care the least about the answers here. It's how to get them that's important. And 1, 2, 0, 9, 60. Okay? Now, we have not talked about repetitions yet. Okay? So repetitions now, like I said, when you have Ross and then you take the 2 S's and mix them up, in permutations, that counts as the same one. You haven't made it more unique. Okay? So with repetitions is a lot easier than you would think. Okay? So I'm going to go right to how it works. Now, the way repetitions works is you take the number of items and divide by all the repeats in factorial. Now, the easiest way to show you that is by doing. Okay, so let's look at the word Vancouver. Now, first of all, 2 things that, if you're going to get these wrong, this is what you're going to do. You're going to count the number of letters wrong, and you're going to miss any repeats. Okay? Promise you that. Everybody will know how to do them. You will mix up the grade 1 stuff. Okay? Because this is a grade 1 question to start it off. How many letters are there? And they'd be able to tell you. I'm not even being facetious here. I'm being serious. You could do this in grade 1. Not the perm part, but say, okay, how many letters? So this puts the pressure on you, eh? How many letters? Let's count. There's 10, right? Just kidding. Okay? So there's 9 letters. How many repeats? 0. 2 V's. See, I told you this isn't easy. I mean, the grade 1s would even take a little less time than you guys did. But they would still be challenged with this one. So there are 2 V's. So all you have to do is go 9 factorial divided by 2 factorial. Because the V's, okay, and that works out to be 181,440. Okay, so if A didn't go well, B's probably going to sting a little bit. How many letters? How many? You sticking with 12? Okay, so there's 12 letters. Okay, so then I got 12 factorial over. What are my repeats? No, tell me how many. There's 2 m's. There is 3 a's, 2 t's. Is that it? Is that your final answer? So then we just divide by 2 factorial, 3 factorial, 2 factorial. Does everyone see where I get the 2, 3, and 2 from? It came from here. So that's what I'm trying to say. This is easy. Can you make sure you collect them correctly? And you're sitting there going, yeah, but I mean, the multiple choice. This is a good numerical response question. Obviously not that huge, right? Because I can't fit in 4 blanks. Four. Okay, so example 7 will probably hit some life memory for you. You remember when you went camping and your parents would buy those little boxes of cereal? Took like 6 of them to even like fill you up. And if you have siblings, did you ever hide a box of cereal somewhere so they didn't get the Fruit Loops when they were... Okay? So luckily Costco has brought these out again, but they're the little round cups, right? And the ones that we had over the weekend, there was 2 Fruit Loops. No, yeah, 2 Fruit Loops. 2 Corn Pops. 2 Special K, and 2 Rice Krispies. Now, what a great way to get rid of Special K in the world, right? Because did you guys ever have the rule you weren't allowed to open the next package till those were done? Yeah, right? Because why else would Costco put Special K in there, right? Or Raisin Bran, right? Like what kid would eat Raisin Bran? That's like little things of cardboard with raisins, right? No kid eats Raisin Bran. But they put them in there, and parents are like, okay, I'll suck it up that you're eating, Fruit Loops, right? And they've actually done, there's more nutritional value in the box the Fruit Loops contain than Fruit Loops themselves, okay? So, but parents are like, fine, I'm going to let you have your Fruit Loops because in 3 days you're eating Raisin Bran, okay? And you know what's coming. It might even come today because you're going through all the rest, right? So, here we are. Brett, an only child, obviously, bought a carton, or let's say his parents did, 10 little mini boxes of cereal. Now there are 3 boxes of Corn Flakes, 2 boxes of Rice Krispies, 1 Cocoa Pop, 1 box of Shreddies, and the remainder are Raisin Bran. Okay, that would be like the crappiest selection in the world. If I was like a kid, I'd be like, okay, this sucks. This sucks. Okay? Right. Over a 10-day period, Brett plans to eat the contents of 1 box of cereal every morning. How many different orders are possible if on the first morning he has Raisin Bran? Now picture getting this one in the diploma. You would probably not even get to be thinking about those fond memories of your childhood. Because you're like, I'm worried about my future right now because of this question. So how would you tackle this one? What if on the first morning you're eating Raisin Bran? Okay, first of all, how many boxes of cereal are there? Okay, so we got 10 boxes, right? So for the first day, you're having raisin bran, right? So you're having one raisin bran. You're not having three, you're having one. So how many boxes do you have to pick from tomorrow? 9, 8, 7, all the way down to 1. So that is the same thing as 9 factorial. Now, would there be 9 factorial ways to eat those? No. Why? Because there's repeats. So let's talk about the repeats. How many raisin bran are there? 2. Do not talk about the first raisin bran. It is gone. Okay, probably hid under a tree somewhere. Okay, now there's 2 left. So there's 2 raisin bran. What else? Any more repeats? 3 cornflakes. 2 Rice Krispies. Any other repeats? Okay, so you could just divide this by 2 factorial, 3 factorial, 2 factorial. Okay? So why are we dividing it? Because you counted it like those 2 were different. I'm dividing it out saying, no, they're not. Okay? So I'm undoing something the top did. That's why I have to divide by the repeats. Because you don't get to have that many choices. Because Ross equals Ross. So you can't count that as 2. So I'm going to divide that out. That's why it's divided by 2 factorial, which is 2. Okay? So we're undoing the top, which would give me 15,120. Who knew there was that many ways to eat your cereal? There are 3, but if, okay, here's how I would put it. Here's how I would put it. If I said I ate my cereal a bunch of different ways, but the first day I had raisin bran, how many ways could I have raisin bran? Just 1. Okay? Then you're talking about them being different. So then I would have 1 small box raisin bran, 1 large box raisin bran. They would turn out to be just like being Rice Krispies and raisin bran. If they are unique, just like Ross, say gave you these letters and they were each different color. Well, now Ross and Ross would be different, wouldn't they? Because it was a blue yellow and a yellow blue, right? So then I wouldn't divide by repeats on Ross. Okay? Now, last one. Okay, so these we used to do a lot more extensively in the past, but they've kind of toned them down a bit, and they're just like, how many routes, how many ways can you get from A to B? Now, there used to be parks in the middle and one-way streets and all that stuff, right? So they're a good time. The rules are, you can never go farther away at any time. Okay, so using common sense. So a route, yes, this is a possible route, but that's a dumb way to do it. Okay? Why would you take that route? And then if you're saying, well, there's a detour, maybe this road is out, well, then that changed the question. I still wouldn't go that way. I would go like this. Okay? So the rules are, you must always be getting closer to B. Now, how many ways do you think there are? Okay, now, here's the old school way to do them. And the only way to do them, if there was a park or a tree or a one-way street or blah, 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 road without a detour, is you would put a 1 here and put 1s all along here. Okay? Now, what is that saying? This isn't saying the number of blocks to get to here. If you were here How many ways are there to get here? Just one way. Do you see that? People say, oh, but you could go like this. There's another way. No. You moved farther away from B. So there's only one way to get from here to here. Same thing from here to here. There's only one way. And same thing from here to here. Now what you want to do is, how many ways are there to get here? 2 ways, isn't there? So what I do is I go like this, and I take an arrow and I go like that, because 1 plus 1 is 2. There's 2 ways to get there. How many ways to here? 1 plus 2 is 3. And how many ways to here? 4. Okay, now let's just think about that for a second. What do I mean 4 ways? We go like this. And correct me if I'm wrong, if I ever have backtracking. I could go, well, first of all, I could go like this. 1, 2, 3, 4. There's 4 ways to get there. Am I missing any ways? Is there another way? Okay. Now, how many ways to get right here? All you do is you take this, and you get 3 there. Here is 3 plus 3 is 6. 6 plus 4 is 10. There's 10 ways to get there. Now the other way is to do it by the blocks. Okay? So this is number of ways to get to each spot. That's how you can do that totally old school. Or, what's the number of blocks to get from A to B? No matter which way you go. Count a route. And it can't be going farther. There's 5, right? 1, 2, 3, 4, 5. No matter how you do it. Right? So you went this way. 1, 2, 3, 4, 5. Do you know there is no shortest way on this one? Okay? Then you got to pretend like you're not going across, right? Like this is like city streets. There's buildings and stuff like that. So the number of blocks is, so you go number of blocks divided by repeats. And the repeats will be downs and rights. Because down and right is the only way you will always get closer. So the number of blocks is 5 factorial divided by number of downs is 2 factorial, and number of rights is 3 factorial. And you'll see those 2 bottom numbers will always equal the top. It should, because those are blocks, right? And if you put that into your calculator, you will get the answer 10 as well. Okay. So, as you're going through these, can you say, oh, that's like the cornflake question. That's like the, okay? And the one thing that I didn't mention is that basically we took this one out of the pool. Okay? I'm going to be using that terminology. Now, a pool is, in this case, is not the thing with water in it. If you've ever done a hockey pool, hockey pool is, here's all the players, pick them, whoever gets the most points by the end of the year wins. Okay? Now, when I was in hockey pools, when Gretzky was at the top of his game, there was 2 ways that many hockey pools went. Number 1, you can't pick Gretzky. Or number 2, if you pick Gretzky, he counts as 2 players out of your 10. Because, and you'll never see this anymore in the sport, but he was so good that if you got Gretzky as first pick, you won the hockey pool. That's how good he was. Your other players did their thing, whatever, got enough, but he was so good that, like, that was a boring hockey pool if, because usually, you know, you pick the order out of a hat or something. There's some random way you pick. So the first guy picks Gretzky, and they were, well, I'm not going to win anyway, right? So how did you make it fair? So the best way to make it fair is to take Gretzky right out of the pool. And the same thing with this one. Take the Raisin Brand right out of the pool. Or if I said that, you know, we're doing a committee and John has to be on the committee, we'll take John out of the pool because I can't, like, he's over here and then we're going to do our bunch of variations here. Okay? So taking it out of the pool, then you go with your 9 factorial. Like, if you know the first number of the combination, that is already done. Then I'm going to mess with all the rest to find out what combinations I'm going to try. Okay? It would be a dumb move to start guessing what the first one is too. When someone gives you information, it increases your chances or lowers the number of chances that you have to try. The more, and it's like, I think it's like anything, the more information you get, the more you study, the less you're guessing. Because if you think about it, a multiple choice test has 4, 4, 4, 4, 4, 4, 4, 4, right? 4 times 4 times 4 times 4. That would be your number of chances. You decrease the number of possibilities the more information you know. Okay? And that's why knowing any inside information increases your chances. And people do their best to try and do that, right? If they're going to the horse race, they want to find out all about the horses. Like if they're serious, they want to find out all the things they can, all the information to lower their chances of not winning, but lower their chances of losing. Okay? Which does increase their chances of winning. So we're doing 1 to 8, 10 to 12.